Well, welcome to our second video for 8.1. We are going to be learning in this video how the circumference um, is related to the diameter. Now, a couple of extra supplies, if you have them, that you could try a little bit of experimenting for yourself is find something, find some string, something round, and some scissors. So, for example, it could be a pop can, could be a roll of toilet paper, a soup can, a bottle, anything that you have that's round, and then you're going to also need some scissors because we're going to be cutting some string. The first thing that I want you to do is wrap the string around what we're going to call the circumference of whatever the circle is that you have. So wrap string all the way around it and cut it so it is the exact same size as the object around, and then set that to the side. Next, I want you to go and stretch another piece of string across the diameter of the circle. For example, on the toilet paper here, we'd have the diameter going all the way across, and then we'd cut it at the edge so it fits the exact diameter of the object. Now, if you have a bottle like this, you'll probably have to guess a little bit as to where the diameter would, or the string should be cut. Then what I want you to do is take the two strings and compare how much longer the circumference string is than the diameter. Go ahead, press pause, do that now. Welcome back. What you should have noticed is if you measured accurately, the circumference string will be a little bit more than 1, 2, 3 times more than the diameter string. Now, the relationship between the diameter and the circumference of a circle, that's what we call pi. And no, it's not the tasty pie that your mom or dad makes. It is mathematical pi, which you can see the symbol down here below. Now, we estimate pi when we write it as a decimal as 3.14, but as you can see in the number below, there is no exact number for pi. It goes on for millions and millions of digits, and it never stops and it never repeats. But we'll use two numbers for pi. One is 3.14, and the other one is going to be a fraction that the ancient Egyptians used, which is 22 over 7. Now, then what it's telling you here is what we just learned, that the relationship between the diameter and the circumference is that is about 3.14 times the diameter, or if it's the radius, remember we have to double the radius to get to the diameter, so we'd have to go the radius times 2, that'll give us the diameter, then we can multiply that by pi. And since we're multiplying here with 2 pi times radius, the order doesn't matter. So I typically like to just double the radius first and then multiply that by 3.14, but you can do it in any order. It will not matter. Now this works for any size circle, no matter how big or how small. Here we're going back to what the ancient Egyptians used, 22 sevenths. And if you notice that a diameter is a multiple of 7, like 14, 21, 28, that this can sometimes be a easier way to do it than times 3.14. And remember, this is only an estimate. Since pi is actually a rational number, it goes on forever, we can always get it really close, but we won't be able to get it exact. So we're going to practice finding a circumference of a circle whose radius is 21. Notice right away that is divisible by 7. So we're going to use 22 sevenths for pi instead of 3.14 in this one. So we have the formula. Circumference is equal to 2 pi times the radius. And now what we're going to do is start filling in what we already know. We know it's 2, and we know that we're going to use 22 sevenths for pi, and we know that the radius is 21. So what we'll do here first is go ahead and notice that 7 goes into both itself and 21. So that leaves us then to multiply out 22 times 2 times 3, which will give us the answer of 132. So our circumference of the circle will be about 132 inches. Now, I want you to try this one. So go ahead and pause the video, and then when you're finished, come back and press play, and we will continue on. Okay, so on the first one, you should have gotten 220 inches all the way around. And then on the next one, you should have got 5 1/2 or 5.5 if you converted it to a decimal. Now, let's see how we do that. So, remember the formula, circumference equals pi times the diameter. So we were going to use 22 sevenths for diameter. So let me get my pencil here, 22 sevenths, and then we are going to multiply that by 70. And remember to turn that into a fraction. We'll just put it over 1. And 7 goes into itself 1 time. 7 goes into 70 10 times. That's going to be 22 times 10, which is 220. And I believe that was centimeters. Nope, that was inches. So 220 inches, and once again, we're just finding the distance around the circle. We are not walking in squares around this circle, so it's just flat out inches. Now, the next one was 7/8, so let's do 22 sevenths times 7/8, which then would leave us, 7 goes into itself once, 7 goes into itself once, so that is equal to 22 over 8. And when you say over, that means divided by. So 8, 16, 24. So let's say 2. And bottom number's 8. And that would leave us with, if we were at 16, that would be 6/8, which can then be simplified to 3/4. Some of you might be saying, Mr. Rolfing, the answer is 5.5. Well, if it's 5.5, what in the world did I do wrong here? Go ahead, pause the video for a moment, and see if you can figure it out. Well, those of you that figured it out knew that that first one you noticed was, we should have done this formula, times it by the radius. Well, being that I can do any order because it's multiplying, this is really comes down to 2 and 3/4, which if I were to multiply that by 2, whoops, that will equal 5 and 1/2. And then let's try another one. Big Ben, a famous clock tower in London, England. The diameter of the clock face is 23 feet, so the diameter all the way across is 23. Find the circumference of the clock face and round it to the nearest tenth. Well, since we know it's the circumference and that we're trying to find, we are going to multiply pi times the diameter, so that will fill in the 3.14, and we will multiply it by the circumference, which is 23, or sorry, the diameter, which is 23 feet. When we do that, we should get 72.2, so the distance all the way around the clock is about 72 and 2/10 feet. Now, go ahead, read this one, try it, and we'll come back with an answer in a minute. Those of you that got 12.6 feet, great job. If you didn't get 12.6, let's do this the correct way. So remember, the formula for finding circumference is going to be pi, which is 3.14, times the diameter, which is 4. So in our calculator, 3.14 times 4 equals 12 and 56/100. It said round to the nearest tenth. So there's our tenth spot. The 6 will make it round up to 12.6. Well, this is the end of today's lesson. You can go ahead and work on your assignment, but before you do that, we are going to do an exit ticket that you will find. It'll be on a Google form under this assignment on Google Classroom. Go ahead and this is going to be today's question. You are going to find the diameter and the circumference of a circle with a radius of 5 miles, round it to the nearest tenth. So get your calculators out and get going on that. Then complete your assignment, take pictures of it, and attach it to the assignment, and you can, when you're done, you can turn it in. Thank you, and have a great day.